So in this video we're going to talk about volume. We already talked about nets and surface area, so your objective is that you can find a volume of certain solids. The volume, I like to think of volume as what you're going to take to fill an object. That's why I have a water pitcher right here. So volume is the space inside a solid figure. How much would it actually take to fill if you had, for say, a box? How much is in there? How much is actually inside the box? So how do we define volume? Well, in volume, you always are going to have a base and you're going to have a height. So you need to identify the base and the height. Now the height, this is not the slant height. Okay? This height is always perpendicular to the base. So the volume is area of the base times a height. That is your formula, and that works for prisms and cylinders. So that, or we denote that as volume equals BH. Now when it's a cone and a pyramid, it is 1/3 area of the base times the height. So the only difference between that one and this one is the 1/3. And then the sphere will have another one, and when we get to that side, we will do that one. So first we are going to do a prism. Now to find the volume of the prism, you need to find the base. Now you have to be careful with the bases and what students tend to struggle with. Base does not always mean, so base does not equal bottom. Okay? The base is that they have to be parallel and kind of unique. The only difference is a rectangular prism, you don't have to worry about this. But so in this one, I could have this on the side, but my bases are still going to be the two hexagons on top and bottom because they're unique, where the rest are just rectangles, even though I have some that are parallel to each other. So I need to find the volume of this figure. So I need to find the area of my base, alright, which is my hexagon. Remember the area formula for a regular hexagon is 1/2 AP. We know the sides are all 12, so we have the perimeter, and I actually also give you the apothem, which is 6 square root of 3. So I can find the area of the base, which is 1/2 AP. So 6 square root of 3 times the perimeter, which is 12 times 6. 12, length of each side is 12 times 6. Alright, and that gives me and you should be doing this with me in your calculator to make sure you're getting the same answer, 374.1. So that's the area of my base. And then I'm going to take it times the height. Now the height is what's in between, how far are the two bases apart, which in this case is 7 is my height. So I'm going to take the area of my base, which is 374.1, and take it times 7. And my volume is 2,618.9. Now since it's volume are cube units, so this would be cubed centimeters. Even though this looks like centimeters cubed, we say cubed centimeters, just like squared centimeters. Alright, so here's our second prism. So this is the case where a lot of students will think the base is this rectangle on the bottom because that's what it's actually set on, which is completely wrong. Your base are actually the trapezoids on the side because they are unique. So I need to find the area of my trapezoid. So the formula for our area of trapezoid is 1/2 B1 plus B2 times your height. So I have 1/2, my two bases of this trapezoid, looks like they're 6 and 9, so I go 6 plus 9 times the height of my trapezoid is 7. So calculating this out, the area of this is 52.5 squared inches. So to do my volume formula, area of the base times the height, the area of the base is 52.5. The height of my prism is how far apart are my two bases. What is that length? Which is 4. I'm going to take it times 4. And I get my volume to be 210 cubed inches. So again, my height is is how far apart my two bases. This was my base because it was unique, not always what's on the bottom. So again, let's look at our cylinder. I'm going to find the volume of this cylinder. Again, we don't really need the net, but just a reminder what the net is. So your base is the circle, no matter if it's on the side or not, like this one. Even though it's on the side, my base is still the circle. So the area of my circle is pi r squared. So area of the base, still area of the base times the height. And notice the height is how far apart the two circles are. So we go pi, my radius, this is 6, so my radius is 3 squared. Alright, which is 9 pi. That's the area of my base. My height, how far apart are the two circles? They are 21. So I go 9 pi times 21. 9 times 21 times second pi. It's 593.8, and that is cubic yards. Alright, so now we have a pyramid. So a pyramid and cone are different because now we have 1/3 area of the base times the height. Again, the reason it's a big B because it's area. Little b means just a base. It's a length. Alright, so my base on pyramids are always that unique bottom, what you would set it on if you would actually put it on the ground because you wouldn't set it on the point. So in this case, it is a rectangle. So I find the area of my base, which is 5 times 3, which is 15. Alright, and now my height is in the middle. It is not the slant height. We use that for surface area. We use the height that's in the middle for volume. So I'm going to go 5 times 3 times my height of my pyramid, which is 4 from the center to the top. And then I have to take it times 1/3 or divide my answer by 3. And this comes out to be 20 cubic inches. A lot of students forget to divide by 3, but anything pointed is 1/3 of the volume. Alright, now we have a cone. A cone, again, remember, is 1/3 area of the base times the height. Alright, our base is going to be the circle, and then we're going to use the height, again, not the slant height, that's for surface area, this height is for volume. So here, on this one, I can definitely get the area of my base, pi r squared, because it's a circle. So pi 5 squared gives me 25 pi. But I need the height. Now they give me my slant height, but that doesn't do me any good in this example. That would have did perfect for surface area, but not for volume. So I need to find my height. Well, I know this is 8, so I'm going to use that trusted Pythagorean theorem. Squared equals 8 squared. And then doing all the calculations, we get our height to actually come out to be the decimal 6.2. So now I can find the volume. It is 1/3 area of my base, which is 25 pi, times the height, which is 6.2. 6.2. I get 162.3 cubic centimeters. And last but not least, we have a sphere, and this one has a formula which is kind of similar to the other one, so students tend to get them mixed up a little. They both have pi in them. Now remember before surface area, it was 4 pi r squared. That was surface area. Well, the volume formula is 4/3 pi r cubed. Because we're finding volume units cubed, so it's r cubed, and then 4/3. So instead of 4, it's 4/3. So find the volume, I give you the radius, which is 4, so I'm going to go 4/3 pi 4 cubed, and that one you just plug in and calculate. And I get 268.1 centimeters, or cubic centimeters. Alright, so review. Volume is how much it takes to fill a solid object. So we have our prisms and cones with volume of base times the height, and then remember, be careful on the base. Does not mean bottom. Right, parent, right here, bases are parallel and congruent to each other, but they're unique. Not always bottom. Okay, if there's something more unique than a rectangle, that's your base. Cones and pyramids, it's 1/3 base times area of the base times the height. And kind of remember the point. Anything with a point has the 1/3. And then the area volume of a sphere is 4/3 pi r cubed. And that is it for volume.